So here are some important utilities that could help you in improving your productivity, and these are quite extensive, so we will actually have some demo where we can see more details. Find is one utility which helps you in locating files and processing those files which are satisfying the conditions that you gave for the searching. tar and gzip are tools which are useful for packaging collections of files, and make is a utility to have conditional actions performed. Actually, make is meant for conditional compilation of source codes, but it's a very generic tool, so it need not be limited to compilation of source codes like C or C++ or Fortran, but actually to do any other action also. So you can think of it as yet another way of writing a script that would work on the command prompt. The syntax of find command is very simple. After the find, you need to give a list of path names followed by the conditions. Typical conditions are listed here. So minus name followed by a pattern to match the file names. So the pattern can be like what the bash would expect. So with a star or wild characters that are interpreted by bash. Then minus type is a condition where you could actually tell what type of a file are you looking for. And the code is C for character file, D for directory, L for symbolic link, etc. Minus a time is a condition to check how many days back was the file accessed. So was it like plus 30, that means more than 30 days back, or minus 30, less than 30 days back. So this is useful in finding out what are the recently accessed files or what are the one of the oldest files touched in the system. Minus c time is very similar to minus a time, except that the files that are being searched are looked at when they were modified rather than just merely accessed. Minus regex is also a condition where you could give a regular expression by also mentioning what type of a regular expression are you using, POSIX basic or POSIX egrep, etc. So that the file names using the complete path name can be looked at in a very powerful manner. Minus exec is an extremely useful condition where you can follow it up with a command, and in the command you could use the two braces as the placeholder for the file name which has been searched by the find command. Minus print is a condition where there is no value that is applied after that, and what it does is just merely to print the file name which has matched the pattern that you were searching for. We need to package files for multiple reasons. So if you have many subdirectories and directories under them, etc., so actions like copying the directory across or looking through those directories for some specific file, etc., would be very slow. So very deep file hierarchies are not recommended, and in situations where such hierarchies are present but you don't need them immediately, it's a good idea to convert the entire file hierarchy into a single file and then store it as a package. So tar is a command, tape archive, which can be used to convert a file hierarchy into a single tar file. Sometimes when you have a very large number of tiny files, each file would occupy the minimum block size that is recommended or required for the file system, so there is a wastage of space. So in such situations also, simply tarring a whole bunch of tiny files would actually save some disk space for you. And gzip is a compressing utility to reduce the file occupancy of the tar file or any other large file in your file system. And where do we use these tools? We have the applications of these tools like tar and gzip in situations where we take backup, when we want to share a file across the internet, or just simply to reduce the disk utilization of the files in our directory. Now there are multiple possibilities that are available for you to just simply club all files into a single file and tar is one of the options, tape archive, but zip is also another option. Zip would actually also compress the files while it is actually pulling them together. And if you are having a file, either a tape archive file or any other file that is large in size, you could reduce its size by many utilities. Compress, gzip, bzip2, xz, 7z are the tools that are useful in reducing the size of a file. Particularly if you have ASCII files, plain text files, they can be compressed to a very good ratio, almost like 1:10, if the file contains many repeating patterns. Now in the brackets I have given the package names which would let you have those tools installed on your system. And very often when you have a huge set of files bundled together as a tar file, and then after that you gzip it to reduce the size and then give it to someone, the other user, when they unzip it, the tar file would be still very big for them before they expand it to the respective file hierarchy. So you can actually have a possibility of zipping the files while adding into the tar file, and so .tgz file format, that is combining tar as well as gzip together, is also a very good option. And which of the utilities, 7z or bzip2 or gzip, which of these utilities should I use? So the decision is made by looking at how much time does it take to compress a file and how much of memory is required to do that particular compression, and also how much time and memory are required to expand it. So very often compress does the job very fast, but the compression ratio is not great. gzip is a very sweet intermediary. bzip2 would do a very good job of compressing by giving a very good ratio, but then it would occupy more space and take little more time to do the job. And there are also other utilities to do the same thing of bundling the files together, like a rar format, which is popular in Windows ecosystem, but it's a good idea to use those tools which are having some portability. So the tools I am mentioning here are open source tools available for all platforms. So if you use these tools for the bundling of files and compressing them, then you can uncompress and unbundle those files quite easily because the tools are open source and freely available. And it's also useful to learn how to stamp a date and time as well as the process ID along with a tar file for backup, so that unique file names are available when you are backing up some important pieces of information from your system at regular intervals. Make is a utility originally meant for compilation, and you can actually create a script and pass it on as an option to the make using the -f option, and it would actually do certain actions for you. Apart from compiling the source codes, it can also do some actions for you. So the most important syntax that you must know is that there is a target colon prerequisites, and below that with a indent the recipe of action that has to be taken. So that is the most important piece of information that has to be in the make file. And here is an example script which we would actually try out on the command line as a demonstration. Makefiles can be used to do conditional running of a script, which is slightly powerful feature compared to just a plain bash script. So let us explore these on the command prompt once. So now let us look at the find command. So the find help man page is available. So it's quite long, and there are some examples also given here, so you could look at them. Okay, so the simplest way of running is find and then the path name, which is the home directory, and an action which is like print the file names. So what it does is just looks at the entire home directory, and every file that is found, it will just print out the file name. So you can actually find out how many files are there in the home directory simply by using this command. So in my home directory, I have 70,000 files. Of course, you may be wondering how come I have so many files. Most of them are actually cache files from the browser and other utilities that are running. Now let us say what are the files that were modified in the last 2 days which require me to basically take a backup, for example. So I can here is a command where in the home directory files that were modified in the last 2 days are being printed out. So obviously the cache folder will also be there, but you also see that there are a bunch of other files that are being reported. So I go to the documents folder and run the command to find out what are the files that are modified in the last 2 days. And this is a small folder, so I have a limited number of files that will be listed, and here are the files that are there. And I go to my home directory and I can say how many files are modified more than a month back. And you can see that obviously some cache files also listed, but there are a bunch of other files that are also there, which actually tell me that there are some files that I have not looked at in the last 1 month. Some more examples. Let us say there are some man pages that are available in the user directory, and I want to know where are those directories kept. So let us try that out. Find /user. So go to the /user directory and minus type D. That means find out those files of the type directory, and the name should be man star. So the name should contain the pattern man. After that, anything else can be followed. And what should I do? I should just print out those directory names onto the screen. So this is a command. So find command actually goes through the entire directory hierarchy and then looks at the options that we have given to see what are the matching or suitable files of the type that we are asking and the name that we are asking, and then print them out. So as it is going through, it may take some time because of the depth of the hierarchy that is available. And you see that it already started to give the output. So here you see that the manual page directories are all here, user share man, and then man 1 to man 8. They are the different sections of the man page that are being listed. Of course, there are also other directories being listed which are having the word man as a part of them. Okay, so what I could also now do is instead of star, I can put a question mark so that only one character has to be there after man. And you now see that it is a slightly lesser list because it has only one character after man that we are trying to match. So you can look for directories as well as for files. Now let us say we want to look at what are the files that are larger than a particular limit. So I want to see what files are more than 100 MB, for example, and I want to print them out to see whether I need to move them out or compress them to save some disk space and so on. So here what we are doing is in the current directory, my home directory, I am looking at files which are greater than 10 megabytes and I want to just print them out. So I have a lot of that files. Now just merely printing them doesn't help me because I don't know the individual sizes. So what I would do is I would like to execute a code on them, and the execution of the code should be ls minus ls and h, so that the human readable size of the file should be listed along with the file name and its long listing. And what is the file name? I am using the placeholder which is the braces side by side, and I need to close the line, execution line, so I escape the semicolon because that is interpreted by shell in a different manner, so I just pass it on only to the find command that way. Okay, so what will happen is that every file that is matching the condition of being greater than 10 megabytes, that file name will be inserted at the place that I am indicating here, and the command that is listed here will be executed, which is basically ls minus lsh file name. So you know what the output would look like. So the output would have the file size in a human readable form followed by the long listing. So you now see that we are able to look at the file sizes of all those which are larger than 10 megabytes. So we can then go to 100 megabytes and look at the large files. So it seems that I have very large number of files that are also very big. So I go for 500 mega, maybe 200. Okay, so I still have large number of files that are so huge. So these are all basically the videos I have prepared for this very course, and I can now see if some of them need to be compressed. So I can go on to compress and see whether I can save some space. I could also look for a particular type of a file and then do an action. So every JPEG file, for example, I want to just see whether any of those are large in size. So what this command does is, in the current directory, it will go on to look for all the files which have a pattern of the name star.jpg, and then on them it will execute the command ls minus sh and then the pattern. So you can see all the JPEG files are listed and their size is given in a human readable fashion here. And so if I see that some of them are too big and I want to do something to them, like reduce the number of pixels, etc., I can do that. So you could actually use the find utility to identify the type of files that you want to work on them. So exec is a very powerful option on them, and the syntax here is very specific. So you have to escape the semicolon, and remember that this will be executed on every file that matches the particular pattern that we gave. So you could also move those files to a different place using the exec command, but you know that those actions are quite serious, and so use them as you deem necessary for your directory. Now to illustrate the compression capability, etc., let me get a copy of the log folders, because that is something that I can try out. So copy -r where log to a folder called log files. So there are some files that I am not supposed to be having permission to read. So nevertheless, the rest of them are available. So you see that a bunch of files have come. Okay, so these are all the log files that have come, and I can find out how much size it occupies. 450 megabytes of size. Okay, and minus LR will give me recursively, and I can see that a lot of depth is there here. So what I can do is tar. So first let me just see. So it is occupying 450 megabytes. So what I will do is tar minus cvf log files dot tar. So here what I am doing is I am creating a bundle of all the files which are in the directory called log files, and I am naming the bundle as log files dot tar. Okay, so it is now bundling, and that bundle, if you see here, it has roughly the same size. You know, it's almost the same size. So 460 megabytes, about 10 megabytes more, because it has to have the information about those files in which sequence it is keeping in the particular tape archive file. Now I can compress this and see how much it can come down. So you see now the file has been shrunk from 460 megabytes to 23 megabytes. That's a ratio of almost 1:20. And that is because the log files are mainly text files, and they have very repetitive kind of pattern inside them, and therefore I can actually keep the entire log files directory with just about 5% of the size that would occupy otherwise. Okay. Now let us look at the efficiency of compression with the other utilities also. So I would unzip that. So it is 460 megabytes. So now I will zip it using another utility, bzip2. As you can make out, it takes a little more time than gzip, and it has shrunk it to 16 megabytes instead of 23 megabytes, which means that bzip2 is slightly more efficient in shrinking, but it takes more time to shrink it. Now that is a balance that you need to pick. Okay, so if you are desperate and you have enough RAM that this compression process can finish in reasonable time, you can actually shrink it to the maximum possible using bzip2. But if you are having limited resources, then gzip is pretty good. Now there is some other utility which also takes a little less time, so that's called compress. I am unzipping the file so that I can try another algorithm. So compress, so you see that the compress has done quite fast, but it has shrunk it to only 45 megabytes. So you can see that compress is very fast, but it shrinks not so much. bzip2 is a bit slow, but it shrinks very well, and gzip is something in between. Okay, so you have to choose what you like to use for a particular application. But in any case, for a directory which has a lot of subdirectories and lot of small files, it's always a good idea to package those as a tar file if you don't need those files regularly. So whenever you need them, you can always untar the file and start using them again. So how do I do that? So the directory is log files is already there, so I remove that. So now you see that the directory is not there, so I would uncompress and tar minus xvf, and now the directory is back. Okay, so you see that we are able to unzip and untar the archive files quite quickly. So it's a very good idea to invest some time in mastering this particular utility, which could save you a lot of space and also effort in transferring files across systems if you have large number of them in a very deep hierarchy of file system. The make utility is also useful as a shell script extension for some maintenance activities. As I mentioned to you, it is actually meant for conditional compilation of source codes, but let us use it for also other purposes. So the man page is quite extensive. You can read through that, and an example of that is available. So here is an example I have created. So what it does is a variable has been created which has the value of the directory, which is a destination for keeping the backup, and then I am storing the date time stamp by using a shell command so that it's actually stored in a variable. Now this colon in front of the equal to is like a one time substitution of this particular variable, whereas if you have equal to, then that means that every time this particular variable is occurring, the substitution is performed. It's a small difference between those two usages in make syntax. And the name of the tar file is being given here as backup underscore the stamp dot tar. Okay, and what am I backing up? I am backing up two files, file 1 and file 2, and the actions are all listed here, where I am displaying a text saying I am backing up the files, and then I am making a tar file, and then I am looking at the size of the tar file, and then I am moving it to the backup directory. So let me make a directory for backup. So the directory is available. And the files that I need to backup are also to be created. So let me create them using touch file 1, touch file 2, and there is nothing in them yet. So what I would do is copy in the log files. So there are some contents that I could copy across. So DMESG. So let me see the size of it. So that's pretty large. Okay. So copy that to file 1 and also file 2. Okay. So now I have got file 1 and file 2 that are there, and make file. So make backup. Okay. So when I run like that, what it would do is it would actually look at a file called Makefile that is available, and in that Makefile, what are the commands available? One of the targets is to be written as backup, and it will try to perform that particular action, what is given below it with an indentation. But we don't have a file called Makefile, so we need to tell that file saying that it's the commands are all actually in make.file, not in Makefile with a capital M. So when we run that, what it does is it would actually back up those two files to a directory called backup under the home directory and as a tar file. So let us look at the contents of the backup directory, and you can see that it has a tar file which contains a date timestamp, and it contains the two files that we have just now wanted to backup. Now this is a very nice utility because every time you run, it would actually change the file name. So what's the date? So you can see that now the time is different. So let us go ahead and try that again. Makefile would perform actions only when the target files have changed. So I have already backed up the file 1 and file 2. They have not changed, so the backup need not be performed. So what I will do is I would append some text to the file 1 so that the file name has changed, file content has changed. So now if I try to make the backup, it would actually do it because one of the files has changed. So this is a powerful feature of make, where one of the dependencies has changed, only then the action is performed, which is actually something that we don't need to worry in a bash script because that is automatically performed by the make utility. So look at the directory. Now you have got two backup folders, and these are with the two different names because we have run them at two different instances of time. So you can actually use the make utility for such actions as cleaning up the directory of temporary files, or zipping things that you don't want to occupy the file system with, and so on. Any maintenance activity can also be taken up as a Makefile command.